Let's start out with a problem. Suppose we need to show with induction that if T is a full binary tree, then the number of nodes in that tree is less than or equal to 2 raised to the power of h of t plus 1 minus 1, where here h of t is the height of the tree. How are we going to do this? Alright, so let's do the proof. So remember, this is what we're trying to prove. If T is a full binary tree, the number of nodes in the tree is less than or equal to this formula. So let's look at our base case. In our base case, T is a full binary tree and it's just got one node, that root node R. So the height of that tree is 0. We defined that from before. And so if we plug that into our formula, so we have then 2 to the power of 0, because the height of that tree is 0, plus 1 minus 1. Well, that means it's 2 to the 1, so that's 2, minus 1, which is 1, and that is less than or equal to 1. Sweet, we've got it done. So that was the simple part. Now let's move on a little bit to the next step, where we're going to do our induction. So now we'll suppose T1 and T2 are existing full binary trees, and suppose that our induction hypothesis holds for each of those. That is, the number of nodes in each of those trees is less than or equal to this little formula for each of those trees. We'll also suppose that T, the new one that we're trying to build, is the combination of T1 and T2 with our one additional root node R. So let's go through our proof step by step and see what we can show. First off, by definition, the number of nodes in our tree is 1 plus the number of nodes in the left tree plus the number of nodes in the right tree. The height of our tree is 1 plus the maximum height of either the left side or the right side. Whichever tree is bigger, we take that height, we add 1, that's the height of our new tree. Now, by our induction hypothesis, the number of nodes in our tree, which is 1 plus the number of nodes in T1, number of nodes in T2, must be less than or equal to 1 plus, and now we can substitute the, using the induction hypothesis, the number of nodes in T1 with the formula that we have from before, namely 2 raised to the power of the height plus 1, all subtract 1 for each of these. Doing some arithmetic, we can cancel out the minus 1 and the plus 1, and what we're left with is these two terms, 2 raised to the power of each respective height plus 1, each again, and then with just 1 minus 1 left. Now the sum of these must be less than or equal to the larger of them doubled, so that means we have this is less than or equal to double the maximum of these two terms minus 1. We also can see that in common between these two terms is the base 2 raised to these powers. So if we take the 2 out of this maximum term, we end up with 2 times 2 raised to the power of the maximum of either height of the tree plus 1 or height of the tree plus 2. And we also can take the plus 1 out of either side because, once again, we're just looking at which is bigger, the height of the first tree or the height of the second tree. We can add the 1 afterwards. Now, if you are really careful, you can notice that this term we have here, the maximum of the height of the first tree or the height of the second tree plus 1, is this definition that we have over here, namely the height of our tree that we're currently working with. So we substitute that in using our definition, and now we have 2 times 2 raised to the power of the height of our current tree minus 1. And so since the base of these two are the same, we can change that into 2 to the power of the height of the tree plus 1 minus 1, which is what we wanted to show with our proof. So hopefully that was a good example of structural induction, and hopefully it was useful to you. Look forward to you guys looking at my videos in the future. Thanks for watching.